Ever wondered how web applications in Java work? Today we're delving into the world of Java servlets. These are an essential component of Java-based web application development, serving as the building blocks for interacting with web requests and generating dynamic web content. They run on a server-side web server or application server, which handles HTTP requests and responses, making them integral to creating web applications in Java. Now you might be wondering, what exactly are Java servlets? Well, servlets are Java programs that extend the capabilities of servers that host applications accessed by way of a request-response programming model. Unlike a typical Java class, servlets are uniquely designed to handle requests from web clients, typically browsers, and can respond with either textual data, such as HTML, XML, JSON, or binary data, like an image or a file download. Java servlets are part of the Java Enterprise Edition, now known as Jakarta EE, and they utilize classes and interfaces from the javax.servlet and javax.servlet.HTTP packages. These include HTTP-Servlet, HTTP-Servlet Request, HTTP-Servlet Response, and others. They're typically configured in the web application's web.ml file or through annotations in the servlet class. Configuration includes URL mappings, initialization parameters, and other setup requirements. The lifecycle of a servlet is managed by the servlet container. This includes initialization, service handling, and destruction. The service method is called to process each request and is a pivotal method where the logic to handle different types of HTTP requests, such as GET and POST, is defined. By default, the servlet container creates only one instance of each servlet and calls its service method for each request in a separate thread. This means servlets must handle concurrent requests and be thread-safe. So in essence, servlets are the building blocks of any robust Java-based web application. They provide a powerful way to handle HTTP requests and generate dynamic content on the server side. They are robust, secure, and provide a standard way to extend any application server's capabilities that supports the Java Servlet API. Now, let's get to grips with some of the key concepts and features of Java servlets. Firstly, we should talk about the servlet lifecycle. This is managed by the servlet container, which could be Apache Tomcat, Jetty, or Glassfish. The lifecycle includes initialization, service handling, and destruction. The pivotal method here is the service method. It's called to process each request and is where the logic to handle different types of HTTP requests, such as GET or POST, is defined. Next, let's discuss the Servlet API. Servlets are part of the Java Enterprise Edition, now known as Jakarta EE. They utilize classes and interfaces from the javax.servlet and javax.servlet.TTP packages. Some of these include HTTP-Servlet, HTTP-Servlet Request, HTTP-Servlet Response, among others. Moving on to configuration. Servlets are typically configured in the web application's web.ml file or through annotations in the servlet class. Configuration includes URL mappings, initialization parameters, and other setup requirements. Now, a word about concurrency. By default, the servlet container creates only one instance of each servlet and calls its service method for each request in a separate thread. This means servlets must be ready to handle concurrent requests and be thread-safe. To sum up, the servlet lifecycle is like the life story of your servlet, from birth to death, managed by the servlet container. The Servlet API is the toolset your servlet uses to interact with the web. Configuration is your servlet's blueprint, defining how it's set up and how it interacts with the web. And concurrency? That's your servlet's ability to multitask, handling multiple requests at the same time. Understanding these key concepts is vital to effectively use and manage Java servlets in web applications. With the basics under our belt, we can now explore the development process for Java servlets. Firstly, you'll need to set up your environment. This involves installing a Java Development Kit or JDK, which provides the tools necessary to write, compile, and debug Java applications. Alongside this, you'll also need a servlet container such as Apache Tomcat, which is responsible for managing the lifecycle of your servlets and handling HTTP requests and responses. Once your environment is ready, the next step is to create your servlet. This is done by extending the HTTP-Servlet class and overriding at least one of its methods. Typically, you'll override the doGetter method for handling HTTP GET requests, or doPost for POST requests. These methods are where you define the logic to process the incoming request and generate the appropriate response. After you've written your servlet, the next step is compiling and deploying it. To compile your servlet, use the javax command provided by the JDK. This will generate a bytecode file with a class extension that can be executed by the Java virtual machine. Once compiled, your servlet along with any other necessary resources such as HTML files or configuration files should be packaged into a web archive or WAR file. This WAR file can then be deployed to your servlet container. Finally, you'll need to map your HTTP requests to your servlet. This mapping tells the servlet container which servlet to invoke based on the incoming request URL. This can be done in one of two ways, either by defining the mapping in the web.ml file or by using the @web.servlet annotation in your servlet class. The choice between the two often comes down to personal preference or the specific needs of your application. And there you have it, a simple guide to developing your own Java servlet. But where exactly would you use these servlets? Let's explore some common use cases. Java servlets aren't just theoretical constructs. They have practical applications in real-world web development scenarios. One of the most fundamental uses for servlets is generating dynamic web content. Unlike static HTML pages that remain the same for every user, dynamic web pages change based on user input or other factors. Servlets can interact with databases or other data sources, process this data, and then generate HTML or JSON based on the user's request. This means you could create a web page that shows personalized greetings, provides real-time weather updates, or displays user-specific information, all using Java servlets. Next up, we have form data handling. Let's say you're building a website with a contact form. When a user fills out the form and hits submit, that data needs to be processed. This is where servlets come in. They can accept this data, process it, for example, validating input or saving it to a database, and then respond back to the client, perhaps with a "thank you for contacting us" message. Lastly, servlets also play a crucial role in session management. As HTTP is a stateless protocol, it doesn't maintain user state across multiple requests. However, web applications often need to track user activity across multiple pages or even multiple visits. Servlets can manage sessions through HTTP cookies and the HTTP Session API. For example, when a user logs into a website, a servlet could create a new session, store the user's login details in that session, and then use a cookie to track that session across multiple requests. This way, the user stays logged in as they navigate through different pages on the site. These are just a few examples of how Java servlets can be deployed to create dynamic and interactive web applications. Now, let's bring it all together and recap what we've learned about Java servlets. We've delved into the fascinating world of Java-based web application development, where servlets play a key role. Extending the capabilities of servers, these Java programs allow for interaction with web requests and generation of dynamic web content. Servlets operate on a server-side web server or application server, handling HTTP requests and responses. This makes them a cornerstone in Java web application creation. But what sets servlets apart from a typical Java class is their ability to process requests from web clients and respond with either textual or binary data. We've also discussed key concepts and features that make servlets tick. The servlet lifecycle, managed by the servlet container, includes initialization, service handling, and destruction. The servlet API, part of the Jakarta EE, uses classes and interfaces from the javax. Servlet and javax.servlet JTP packages. Servlets are configured in the web application's web.ml file or through annotations in the servlet class. And let's not forget that servlets are designed to handle concurrent requests and be thread safe. In terms of the development process, we've explored setting up the environment, creating a servlet, compiling and deploying and mapping requests. Servlets interact with databases or other data sources to generate dynamic web content, process and respond to web form data, and manage sessions, all crucial tasks in any web application. So we can see that Java servlets are not just powerful, but they're robust and secure too. They provide a standard way to extend any application server's capabilities that supports the Java Servlet API. And that's a wrap on Java servlets, a powerful tool in the arsenal of any Java web application developer. Thanks for joining us, and don't forget to like, share, and subscribe for more tech insights.